Hey, applied pre-calc. So you made it past the slopes. It's still a little bit weird because you didn't know what the equation of a line is. We're going to start looking at that here today. So this one starts off with slope-intercept form. There's going to be two other equations of, well, actually three more that we're going to look at a little bit later. But this is probably the most useful one. The equation, or in slope-intercept form, the equation is y equals mx plus b. Now, if you recall, we already defined m previously. Do you remember what m stands for? Yeah, that's right. M is our slope. So if you know what our slope is, you know what the m value is in this equation. X will always be your x coordinate. Because it's a variable, we can just leave it as x, but when we're solving for things later on, you'll see how to do that. You can plug numbers directly into our equation. And y would be your corresponding y coordinate. So you're always solving for the y coordinate. Your x value is always multiplying with your slope. And then you're adding or subtracting this b value. And b is, what really is it? Well, if you go back to the name of the type of line, and this is going to be true with every type of line we look at, the name is a huge hint. Slope-intercept form. It gives us a slope in the equation. It's also going to give us an intercept. B ends up being our y-intercept. If you don't remember from grade 9, an intercept is a point on a line where that line crosses one of your axes. So remember, you always have two axes. You have your horizontal one, your x-axis, your vertical one, which is your y-axis. Well, when one of those lines are crossed, we call that an intercept. Anytime we're crossing the y-axis, our x-coordinate will always be 0 in that case. And anytime we're crossing the x-axis, our y-coordinate will be 0 in that case. And when I'm referring to coordinates, it's a point. A point must have an x and a y coordinate, so you're always solving for the other. So there's about three major types of problems that I can ask you with regards to slope-intercept form. We're going to take a look at an example for each of those. The first one is if I ask you to determine the equation of a line. So in this case here, I've drawn a line for you. What is the equation of that line? Well, remember, we always have the same equation for slope-intercept form. It's going to be y equals mx plus b. Now, pay attention to the question, because later on, once we learn other types of lines, I'll ask you what type of equation I want to see. So determine the equation of a line given in slope-intercept form. You'll write y equals mx plus b to start. The next thing you have to do is figure out what some of those values are. Now, if a line is already given to you, we can already figure out the m, the slope, and the b value, the y-intercept. I'm going to start with the b value because that's what slope-intercept form is designed to give us. It's where the line crosses the y-axis. So I have to find my y-axis. That's the one that's going up and down here. And at what number does my line cross? Well, it's right over here. I'm going to put an x there. Right there, at -1. So that means my b value is going to be -1. I don't know what y is. I don't know what x is. And I still don't know what my slope is. Well, remember, slope, from what we looked at previously, was rise over run. So I'm going to figure out how much my line goes up and how much it goes over until I find a new point. So I'm going to start at the x, and I have to find another point somewhere on my graph. Ideally, a nice point. And this graph in particular, there is a nice point. I'm going to put a little dot where that is. It's my other intercept. So when solving a problem like this, it's ideal to identify both of your intercepts. The y-intercept gives you the b value, and we can count our rise over run from our y-intercept to our x-intercept to solve for m. So in this case, I move up by 1, so my rise is 1, and I move over by 3. 1, 2, 3. So my run is 3. So rise is 1, my run is 3. The equation of this line is y equals 1/3 x minus 1. Now, can we test this out? Yeah, absolutely. We've already got some points on our graph, so let's plug those into our equation and see if we've actually got it right. So in this case, let's look for our x-intercept here. Our x-intercept exists when y is equal to 0. Our equation becomes 0 equals 1/3 x minus 1, and we only have one variable left, so we had to solve for x. So there's -1 on one side, so we're going to add 1 to both sides to cancel them out. Okay, 1 equals 1/3 x. And if you get x by itself, well, x is multiplied by 1 divided by 3. Multiplying by 1 doesn't do anything. Dividing by 3 is kind of an issue, so I'm going to multiply by 3 on both sides. That cancels out my 3's on one end, and I'm left with 3 times 1 is equal to x, which means 3 equals x. And is that true? Is my x-intercept at 3? 1, 2, 3. It is. Okay, so knowing that you can test your answers, you should never have an issue with these types of linear problems. If you do have an issue, then you know you need to go back and reevaluate what you're looking at.